7, 8, and 9, solving equations with 0, 1, or infinite many solutions. We're used to solving all our equations and getting W equals an answer. But there are some times when your variable could equal any number in the world, and they always would end up being equal on each side, or that when you get when you try to solve it, you're never going to get an answer that works. So we're going to solve these like we solve everything else, or at least we're going to start that way. And so we're going to multiply this out. 5W plus 5 minus W equals 3W minus 3 plus 7. Here, 5W minus W is 4W, so 4W plus 5 equals 3W plus 4. This one is going to solve like it normally does because I can tell my coefficients are different numbers. It's only going to be when your coefficients are the same numbers on opposite sides that they end up canceling each other out. So in this case, I'm going to subtract my 3W, subtract my 5, and I'm going to end up with W equals -1. So they're going to have you click in this circle, type -1 over here, and put your solution in. Second one, using my distributive property. 3W minus 6 minus 5W is going to equal -2W minus 4. Combining my like terms, 3 minus 5 is -2W minus 6 equals -2W minus 4. Now this is one where you're going to have one of those special cases. When I solve this, I'm going to add my 2W and add my 6. I get 0W equals 2. Can 0 times anything equal 2? Well, no, it can't. And so this one's going to be no solution. The only way it's going to work is if 0W equals 0, because 0 times any number is 0. That's when you get the all real numbers are solution. But if you have 0W equals anything other than 0, 2 in this case, I can't take 0 times anything and get 2. No solution is going to be my answer. So number 8 is going to be the same kind of thing here. We want to solve each of those. And so using my distributive property, -3W minus 3 plus 7W equals 4W plus 4 minus 7. Combining my like terms, 7W minus 3W is 4W minus 3. Then I'm going to get 4W, 4 minus 7 minus 3. Notice on this one I have the exact same thing on both sides. If I would go about solving it, I would subtract my 4W and add my 3. I get 0W equals 0. 0 times 1 is 0, 0 times 2 is 0, 0 times 15 is 0, 0 times -983 is still 0. So in this case, you get the all real numbers are solutions. And so we would just go ahead and mark that circle there. Second one, we're going to use our distributive property again. -3W minus 12 minus 2W equals 2W plus 2. So we will get -5W minus 12 equals 2W plus 2. Again, I can tell this is going to solve because my coefficients are different, and I'm going to go ahead and finish it. If I can pick up my pencil. So, minusing my 2W and adding my 12 gives me -7W equals 14. And when I divide, I get -2 for my solution. So I check that middle one, type -2 over there after the W equals. Number 9, same kind of thing. I want to solve each of those. So on the first one, using my distributive property, for x minus 12 minus 6x equals -2x minus 12. 4x minus 6x is negative 2x minus 12 equals negative 2x minus 12. You might remember from the previous one that looked like that, where everything was exactly the same on both sides, that when you solve it, you get 0x equals 0, and that if you get that, all real numbers are solutions, because 0 times anything is going to give you an answer of 0. And the second one, 4v plus 4 minus v is going to equal 3v minus 3 plus 3. So we are going to have 4v minus v is 3v plus 4. Here, negative 3 plus 3 cancels out. I get 3v plus 4 equals 3v plus nothing. If I try to solve that, I would go ahead and subtract that 3v and get 4 equals 0v. Well, we know that nothing times 0 is going to give us 4. So there's one of those no solution ones.